Flipping to the next page, we have our second theorem, and this is also related to tangent segments. And so let's see here. Looking at the diagram, see we have two segments from the same exterior point out here. So both of these segments from the same exterior point are tangent to a circle. If two segments from the same exterior point are tangent to a circle, then they are congruent to each other. So they go to each one of these points of tangency. So if both of these segments from a point outside the circle are tangent, then they must be congruent to each other. All right, that's all that says. Now, I want you to also think about, though, based on our last problem, our last set of theorems, that the radius we know is going to be perpendicular to the tangent segment. So let's just draw those in there just so we can start to see a diagram a little bit. So notice what we've got. Remember, radius are congruent to each other. So really, when we put those two pieces together, we have this kite. And the special kite that has right angles for its non-vertex angles. But remember, we do have a quadrilateral here as well. So that could help us with determining some of these remaining angles. So just bring that up now because that could be helpful in some problems a little bit later in the unit. Okay, so example related to that, A, B, and CB are tangent to circle D. Find the value of X. All right, so we were told in the last one, if these are going to be tangent, that both of these segments are congruent to each other. So this will be a little bit easier problem than the last one. More similar to most of the ones that we've done. So that means x plus 15 is equal to 2x minus 5. So let's see, let's get this x, move it over to the left side. So that leaves us with 15 is equal to x minus 5. Adding 5, we get x is equal to 20. It did say to find the value of x, so not to necessarily find the length of the segment. Length of the segment but would be 20 plus 15 or 35. Coming back to this discussion of inscribed versus circumscribed, we talked about those two terms. Remember, inscribed means it's inside. Circumscribed basically means it's outside or around. So these are circumscribed polygons, where every side of the polygon is going to be tangent to the circle. So it just kind of fits perfectly around the circle. All right, same thing with the hexagon there. And then these would not be circumscribed, so they don't fit perfectly around. This one has a couple of, actually 3 tangent points there, but not this one. And this doesn't have any tangent points. This one maybe has 1 tangent point. So just as a point of fact there with that definition. So we look at now this situation where graphic designer is giving directions to create a larger version of the triangular logo shown. If triangle ABC is circumscribed about circle G, find the perimeter of ABC. So find the distance around. So if it is, that means they're tangent. So each one of these would be a point of tangency. Now let's think about what we had talked about above. Right? We know that from a point outside of the circle, that if we have tangent segments, that they are congruent to each other. So those two segments are congruent to each other. Same thing down here, but with different lengths. So those two are congruent to each other. And then these two are congruent to each other as well. So 1, 2, 3, 1, 2, 3. All right, so let's start to piece together our actual lengths then, because I think this is not going to be overly hard once we've noticed that particular relationship. So if this is 8, this is 8 feet. If this is 7 feet, then this is 7 feet right here. And if we know the entire length is 10 feet, then we know this must be 3 feet. And if we know that's 3 feet, then this is 3 feet. So what is our perimeter then? All right, so here is our entire perimeter. And so now we have 3 plus 8 plus 8 plus 7 plus 7 plus 3. So 2 8s, 2 3s, and 2 7s. All right, so 2 times 3 plus 2 times 8 plus 2 times 7 is 6 plus 16 plus 14, which turns out to be 36. And we do have a label there, so let's put it in there, 36 feet. All right, so that's a particularly large logo now that I'm thinking about it, but maybe it's on the floor of something or on the wall or something like that. But in any case, those are our units, and that totals to 36 feet.